Okay, welcome back. So here what we will discuss is, or actually I'll demonstrate using Creo. When the line is, when the different lines, say in this case I have drawn 5 different lines. And when the line, the inclination with HP remains the same. The inclination with the HP remains the same. The second endpoint, one endpoint I am fixing. I'm fixing one endpoint. See, this endpoint for all the 5 lines, the endpoint here is the same. So I'm fixing it, and each of the line is making the same inclination with the HP. And how it is proven is I can show it to you. So here, see, in the placement, the first angle it is 35 degree. That is, this particular line is making an angle of 35 degree with the horizontal. See, from this one it is evident, that is, it is with the horizontal line. And the first line is making an angle of 10 degree with the VP. So here it is 10 degree. See, here it is 10 degree with the VP. And likewise, the second line. If we go to the second line, the second line is making an angle of same 35 degree with the HP. 35 degree is the angle with HP. So this angle is 35 degree, and 20 degree with the VP also. So that is, the change in angle is only in VP with respect to VP, and with respect to HP, all lines are having that same inclination as 35 degree. So here also I'm taking the third line. See, it is also having 35 degree, and the inclination angle offset in the case of with the VP is, it is 40 degree. So each of line 10, 20, 30, 40 and 50, that is, these are the 5 lines, that is, and each is making an angle of 35 degree with the HP. So if we look to the front view, so let's see the front view. See, here it is not that visible, but here now it is visible. See, each of the line, here the second endpoint is here, here the second endpoint is here, here this is here it is here, second endpoint is here. So that means if we draw a horizontal line, it will pass through all the second endpoints. See, from here, if I draw a horizontal line, it will be passing through all the endpoints. So that is the condition. So that is, and in order to prove that one, I have one more method. I have generated the length. See, in the length, the front view. See, this will be the XY line, this horizontal line. This will be our XY line in this case, or the HP, and from HP, all the points on all the second endpoint is at a distance of 5.74. If you calculate the 5.74, it will be some function of the true length, that is 10 is the true length that is taken, and the angle 35 degree. So it will be some function of those two angles. So it will be a constant. Since the 35 degree is constant, the height of the second endpoint from HP remains the same, keeping the first endpoint as constant, as fixed. Here the first endpoint is fixed. This point is fixed. So that is why this particular distance is same, 5.74. Now if we move on to the top view, see, in the top view also, the length of the line is the same. Length of all the lines is the same, 8.19. But they are arranged in a circular fashion. This is arranged in a circular fashion. As the length, the inclination with the VP changes. This is this first line. This first line is the line with the 10 degree inclination with the VP. This is the line with the 20 degree inclination with the VP. This is the third line with the 30 degree inclination with the VP. And these two figures, they are similar to this figure, that is here. This is rotating, this is in the circular fashion, and here correspondingly it moves in the horizontal direction. So So when B1 was here, B1 dash was here, and when B came here, B dash came here. So here it is moving in the horizontal fashion, that is in the front view, but in the top view it is moving in the circular fashion. So that is evident from the model in Creo. So I hope you understood, and if anybody of you doesn't understood, please clarify it right now itself. The same thing is true for in the case of the top view also, or in the front view also. In the front view also, we have created such a similar thing. So see, B dash, B2 dash, it is in the circular fashion, and here it is B2, B2. B2, B2, it is moving in the horizontal fashion. So any doubts? If there is no doubts, we will move on to the exercises.
Sir, could you explain that B dash B1 same locus point once more?
Yeah, okay. See, we have already shown that the true length, the length of the line, the length of each of these lines is the same. I have created a multiple copies of the same line. That is evident if you go for, sorry, just remove this one. See, the length of each of the line is the same. I hope it is visible to you. So length of each of the lines is the same. In this case, there are 5 lines, 1, 2, 3, 4, and 5. All the 5 lines, the length is the same. That is for sure. That I hope you understood. Now, if I go to the front view, and I have demonstrated that the inclination with HP remains the same, that is 35 degree itself. And the length of the top view, I mean, sorry, not the length, the inclination with HP remains the same, 35 degree, that I have demonstrated. And the inclination with the VP changes from 10 to 50. That is, for first line it is 10 degree, second line it is 30 degree, for third line it is 40 degree, and the fifth line it is 50 degree. That is how it has come. That is how I have arranged all these lines that we have seen in Creo placement window also. Now, if I go to the front view, see, here is the front view of all the lines. So in all the lines, if you look to the top, the second endpoint, see, the first endpoint is fixed. Here, the first endpoint for all the 5 lines is the same. The same point is the first endpoint. If you look into the second endpoint, see here, if you look into the second endpoint, this point, this is the second endpoint, and here this is the second endpoint, here this is the second endpoint, and here this is the second endpoint. If we look like this, or if you draw a horizontal line through any of these points, any of the second endpoints, then all the endpoints, all the second endpoints, or the second endpoints of all the lines should be lying in that particular line. How it comes? The distance, if I mark the distance of this particular points, from the fixed point is the same, or the vertical height is the same. Why is it so? You take your set square, any of your set squares, and you place one of its short edges on your table. You place your set square, any of the set square, either 45 degree or 60 degree, and place any of the shorter side on the horizontal plane, that is your table. Your table can be considered as the horizontal plane in this case. Now, keeping a corner, not the 90 degree corner, the other corner fixed on the table, you just rotate it along the table. You just rotate it along the table such that the vertical edge remains the vertical itself. So in that case, you observe that the second endpoint, the longest edge in the set square can be considered as our line. The longest edge in our set square can be considered as our line, and the endpoint which is fixed is similar to this endpoint, and this point is the second endpoint of that line, and the height of that particular second endpoint always remains the same from the HP. HP is our table. So this is the concept. That is, the height doesn't changes. The height doesn't changes as long as the angle remains the same. The angle with HP in that case is either that 45 degree or the 60 degree, whichever set square you have taken. Depending on that one, the angle changes. But still, for a particular set square, it remains the same. If you have taken the 45 degree, the angle with HP is 45 degree. So in that case, the second endpoint, the height of the second endpoint can be found out using that length multiplied by opposite side, that is sine 45. So that formula, that particular trigonometric function remains the same. That trigonometric value remains the same, the height, as long as the 45 degree doesn't changes. But when you change that particular 45 degree, if you are able to change that particular 45 degree, in that case, that length, the height also changes. But here we are keeping that particular 45 degree constant, and instead of placing our line parallel to the VP, we are placing it at different angles. See here, this line, the rightmost line, that is making only 10 degree with the VP. The second line, this line, it is making an angle of 20 degree with the VP. Here, the third line, that makes 30 degree with the VP. This line makes 40 degree with the VP. This line makes 50 degree with the VP. So each line makes different angles with the VP. Still, the height, the second endpoint will be at the same distance from the XY line or its base point. Since we doesn't changes the base point, the height of the second endpoint will be same or equal for all the different lines from the HP. So that is the concept. So this in class we used to demonstrate it using the set square, but here I'm not able to demonstrate it using the set square. That is why I created a Creo model in order to make it clear for you. Okay, you got it?
Yes, sir. Thank you.
Okay. So now shall we move on to an exercise based on this particular figure? You do one thing, you just note down this figure, because anyway I will be displaying it in the coming slides also. So let's try how this particular figure can be used for solving our problems. Okay. So projection of lines, the first exercise. A line AB has its end A 20 millimeter above HP and 25 millimeter in front of VP. The other end B is 45 millimeter above HP and 55 millimeter in front of VP. The distance between the end projectors is 60 millimeter. Draw its projections. Also find the true length and true inclinations of the line with the HP and the VP. And also draw the traces also mark the traces also. Okay, just 1 minute.
Yes,
TC sorry. Okay, in this particular problem, you just mark the traces also. I haven't written it in the question paper, but you just make it, mark the traces also. Okay, hope all of you have noted down the question. Now let's move on to the solution. As I said, in our normal figure, I have written the normal, I have drawn or displayed the normal figure, the base figure here. Here, the parameters that is given is its center A is 20 millimeter above HP and 25 millimeter in front of VP. So that means this distance, the distance here, it is 20 millimeter. In you don't have to write, and this distance is 25. So these two distance we are given, so that you can draw. And then the next is the other end B is 45 millimeter above HP and 55 millimeter in front of BP. So this distance is 45. That is the distance of B dash from XY line is 45. And the distance of B from XY line, that is 55. This is also given. So all these parameters are given. And the last one is the distance between the end projectors is 60 millimeter. The end projectors is the projectors through A as well as B. So that is A dash, this line, the distance between these two lines. This line as well as this line. This line as well as this line. Distance, that is 60. So these are the dimensions that is given. And everything else we have to find out. So if you draw this figure roughly on your book, and then from one by one we can find out the things, find out the items or the items missing in our figure. So first what you have to do is you have to draw the XY line. All the drawings that we are doing, the first step is to draw the XY line. So first we draw the XY line. So mark X and Y. Now what we do is we got the values of or the distance of A dash and A from the XY line. So we draw a perpendicular line to XY line and mark A dash as well as A. A dash is 20 millimeter above the XY line and A is 25 millimeter below the XY line. Okay, once I will explain this and then you can draw it. Once again I will explain, and in that step, in the second time, you can start drawing. And before that, just listen to what I am explaining. So first we draw the A dash and A. First we mark A dash is 20 millimeter above the XY line and A is 25 millimeter below the XY line. Now we mark, we have to draw B dash as well as B in order to find out the projector through B dash and B. The distance, that is 60 millimeter, is given here. So 60 millimeter from this line, from this vertical line, mark a distance of 60 millimeter and draw another vertical line. And in this vertical line, you mark B dash and B. B dash will be 45 millimeter above the XY line. That is this distance from this point to this point. It should be 45 millimeter. And on the opposite side, it should be 55 millimeter. And now you got A dash, B dash, A and B. Now join the front view as well as top view. Join AB. Now this is the top view. And here A dash, B dash. This is the front view. Now whatever is given in our question, and the first part of that particular question is completed. That is draw its projections. Up to draw its projections, we have completed. Very simple. Now we have to find out the true length and true inclinations of the line. In order to find out the true length, and the true inclination, see, here it is A, B dash. Here it is A dash, B dash. So here also A dash, B dash is there. A dash, B2 dash. This is A dash, B2 dash is parallel to the XY line. We can rotate it like this. Or the other way also is possible. AB. AB is the top view and AB1 is having the same length and with an arc. AB1 is parallel to the XY line and AB is equal to AB1. So what we do is the front view length as well as top view length, that need not be marked on your drawing. Now we draw a line from A dash. So this is the angle alpha. We doesn't need to mark that one. And here also the beta is also marked. And now what we do is we rotate AB. This AB1, B1 is to be found out. This point, B1 is to be found out. So with the A as center and AB as radius, you draw an arc. You draw an arc in this direction. So that AB1 is parallel to XY line. So here is B1. Now from B1, drop a projector to the locus of B dash. In order to find out the locus of B dash, draw a horizontal line through horizontal line parallel to the XY line through B dash. XY line is here and a line which is parallel to XY line and passing through B dash is drawn here. So that is there. And from B1 project to B, draw a projector to the locus of B dash. So here it is, B1 dash is obtained. Now join A dash with the B1 dash. Now the length A dash B1 dash will be the true length, and the inclination of A dash B1 dash with the XY line will give you the true inclination with the HP, that is the theta. This is the true length and this angle is theta. So this is you can do. Now what we do is you rotate the front view in order to get the B2 dash, and from B2 dash you drop a projector to the locus of B. Locus of B is any line which is parallel to XY line and passing through B, and from B2 dash you drop a vertical line to locus of B, and this point is B2, and join A with B2. So this A B2, that is also a true length. So that is A dash B1 dash should be equal to A B2. It should be the same length. If there is some mistake or some changes in the length, that means there is some error, some sort of error that is happened in your drawing, maybe a measurement error or a drawing error, some sort of error. And now the inclination of this line A B2 with the XY line or this angle is phi. That is the true inclination with the VP. Now what you have to do is you have to mark all the dimensions, that is the 60 degree, 20 degree, then this 25 degree, 45 degree and 55 degree. All the dimensions will be marked only at the end. After drawing all these drawings only, all these lines, only you will complete the dimensions. Otherwise what may happen is some of the drawings or some of the lines may overlap or may intersect with the dimension lines, which we want to avoid. So always do the dimensions only after completing all the drawings. Now finally draw a box, and in the box you write down all these parameters, that is the true length, the inclination with HP, the inclination with the VP, the apparent inclination in the front view and apparent inclination in the top view. So that is it. So you be ready for drawing. Once again I will explain, and in that case, in that explanation, during that explanation you can start. Bye. Draw a horizontal line XY. So here also in the base figure we are drawing the XY line. So that same XY line we draw a horizontal line. The horizontal line should be thick and it should be decently long enough to incorporate all these drawings. So and then mark X and Y on both the ends. Now, we have to mark A dash as well as A. In order to do that one, you draw a perpendicular line to XY line somewhere towards the left end, not too close. Something like this should be avoided. Somewhere here, somewhere towards the left 1/3 of the line. you drop any vertical line. The distance from X to this particular vertical line is not of importance. The only thing is you must leave sufficient space towards the left. That is the only thing. A dash. Mark A dash, which is 20 millimeter above the XY line. Likewise, mark A 25 millimeter below the XY line. So A dash and A is marked. Now from this vertical line, mark a distance of 60 millimeter or measure a distance of 60 millimeter along the XY line. This 60 millimeter is distance between the end projectors. The end points are A and B. So the projectors to A and B. These are the end projectors. Mark a distance of 60 millimeter between the end projectors. So from the projector to A and A dash, mark a distance of 60 millimeter along the XY line or parallel to the XY line, and then drop the second projector. And this is the projector for B. And in this one, in the second projector, the point B dash is 45 millimeter above the XY line. So 45 millimeter above the XY line, mark the point B dash. And B is 55 millimeter in front of VP. So that is 55 millimeter below the XY line. Mark point B. This much I hope you have completed. Now join A dash and B dash as well as A and B. A dash, B dash as well as A and B are marked. This is the front view length and this is the top view length. No need to write this front view length as well as the top view length. You don't need to write it. Here actually this is for the explanation purpose. We have given this front view length as well as top view length. You don't have to display it. Now the inclination of A dash, B dash with the XY line, that is alpha, and inclination of AB with the XY line, that is beta. Now actually when you are drawing this particular line, in order to measure the alpha as well as beta, it is always better to extend it to certain length. Extend it to certain length so that it will be easier for you to rotate the front view as well as the top view. Like this line A B1 as well as A dash B2 dash. It is slightly of a longer length. This can be a longer length also, no problem. So alpha and beta are marked. No need to measure them right now. We can measure it at the end. Now take your compass with the A as the center and AB as radius, draw an arc so that the point B1 will be on the line which is parallel to A. Which is parallel to XY line and passing through the point A. So B1 is obtained. So by drawing this arc, this is the arc that we have drawn here, similar to same as this arc. We have drawn an arc here to this arc. And this line also, this horizontal line, AB1. Now you have to find out B1 dash. Once you obtained B1, you have to find out B1 dash. In order to obtain B1 dash, first to draw the locus of B dash. The locus of B dash is a horizontal line which is parallel to the XY line and passing through B dash. Through B dash, parallel to XY line, draw a horizontal line which is the locus of B dash. So this is the locus of B dash. So this is drawn. Now from B1, draw the vertical line. From B1, draw the vertical line to intersect with the locus of B dash. So here, like this. Now it is intersecting, this point is B1 dash. Now join A dash with the B1 dash. A dash is joined with the B1 dash. And this is the true length. By measuring this A dash B1 dash, you will obtain the true length. And the inclination of this line with the horizontal line, this angle, that is theta. That is true inclination with the HP, theta, is the inclination of A dash B1 dash with the XY line or the horizontal. Now what we do is, we rotate A dash B dash, that is this arc. We draw this arc such that A dash B2 dash is parallel to XY line. A dash B2 dash is parallel to XY line. So here it is B2 dash. A dash B2 dash is parallel to the XY line. Now we draw the locus of B. Locus of B is a horizontal line which is parallel to the XY line and passing through the point B. Locus of B is a line parallel to the XY line and passing through B. So this point is obtained, B. B dash and B is obtained. So now from B2 dash, drop a projector to the locus of B. From B2 dash, drop a projector. This line, these vertical lines are known as the projectors. Drop a projector to intersect with the locus of B at a point. This point is B2. Point B2. Now join A and B2. So the length of A, B2 is again the true length. And this length should be equal to A dash B1 dash. A dash B1 dash equal to A B2. And the inclination of A B2 with the horizontal line or with the XY line is known as phi, the true inclination with the VP. True inclination with the VP phi is given here. So now our drawings are complete. Now what we have to do is we have to draw the dimension lines. It is 20 degree, sorry, I mean 20 millimeter. No need to write the millimeter time, only 20 is required. And here it is 25. C is already there. So here it is 45 and here it is 55. So all the dimensions are done. Now you draw a box and in the box you write the dimensions, that is the true length. What is the true length? Instead of writing the true length there, it is always better to write it in a rectangular box. True length theta, then phi, alpha and beta.